So we've talked about rectangular equations, and those are equations that are set on the Cartesian plane, where you have an x and a y coordinate, and so you have two variables. And so today we're going to talk about parametric equations, and that's when you have a curvilinear motion. You have two variables for position. So for example, if you throw a ball, you would have the height, the highest point that that ball goes in the air, and then you would also have the horizontal distance where it lands. But then we also have a variable for time. How long does it take to reach that maximum? How long does it take to hit the ground again? And so then we have three variables there. We have two for distance or position and one for time. So we're going to look at how we can solve problems like this. And they're called parametric equations. So we have the amount of time it takes to go horizontally, and we have the amount of time it takes to go vertically. And so those are represented by two different equations. So depending on the object, it'll change the equation. But anyway, so you can see this example. We have a couple of different equations for this model. All right, so basically for a plane curve, we have f of t is the x value, and g of t is the y value. So we are plugging in our unit of time into each of those functions to get the x and y values of our parametric equation. Okay, and so let's take a look at example number 1. Sketch the curve represented by the parametric equations x equals t and y equals negative 2t in the interval -2 to +2. All right, and so it's always going to be called a curve because it's a parametric equation, so it's a curvilinear motion, and we are on the plane, we are using the plane curve, and so we will take a look at the ordered pairs that we are going to get so that we can graph this. So we have our t values, and we know that they are going to go from -2, so I'm just going to do the whole numbers, and then we'll connect those with a line or a curve. And so we want to find the x values. Well, if our equation is x equals t, then our x values are all the same as our t values. And then we have y equals -2t, so we're plugging in the -2 in for t, and we're getting 4. Then when we plug in -1, we get 2, and then 0, and then -2 and -4. So now we can go ahead and graph those, and we are going to use our x and y columns to graph. And so I'm going to mark off every 2 units, and so each of these line segments represents 2 units, and so I'm just going to label those there. And then I can go ahead and graph my points. So I have the point -2, 4, so I have that point up there. I've got -1, 2, so it's going to be right around there. We have 0, 0. We have 1, -2, and we have 2, -4. Now it says sketch the curve, but this is really a straight line, and actually it should be a line segment because it cannot be less than -2 or greater than 2 for your t value. And that is how you would sketch that set of parametric equations. All right, so let's take a look at the next page. So for example number 2, we want to use a graphing utility like our graphing calculator to graph the curves represented by the parametric equations, using the graph and the vertical line test for which curve is y a function of x. That should say y, not ay. Okay, so the first thing we need to do is go to mode, make sure that we have selected parametric equations. So we're going to go down to function and make sure we hit enter on parametric equations. So now we can go to y equals and see now we have x sub 1 and y sub 1. So x sub 1 is equal to t. So notice that when we hit our variable button, it automatically becomes a t. And then y equals the square root, so second square, and then of t. And then we can make sure our window, we're going to change this. I want my t minimum to be 0 because time is 0. That kind of makes sense. I'm going to, actually I'll make my t minimum -10 because it might not be time, but usually it is. So we're going to make our t maximum 10. I'll make my t step 1. I'm going to leave my x minimum and maximum as -10, 10, and then scales 1, and I'm going to leave all of those things the same. So if yours aren't the same, you can make them the same. And so then we can go ahead and hit the graph button, and notice that it looks like a radical equation. But remember that this is not continuous. It stops at 0. And so y is not a function of x because it is not continuous. If we had the parameter where x had to be greater than 0, then yes, we could say that it is a function because we put that parameter on there, but we don't have that. So in this case, y is not a function of x. So now let's take a look at the second part. X is still equal to t, so we're going to go down to y. And in this case, y is t squared. So let me delete that parenthesis. And then my window is just going to stay the same, so I don't need to do anything there. But I'm going to go ahead and hit my graph button. And you can see that it's a parabola here. And so that is a function because it is continuous along the x-axis and it passes the vertical line test. So this one is a function of x. Okay, so now let's take a look at example 3. We have this set of steps for eliminating a parameter, and we're going to do that here in just a minute. The first thing we do, we have two parametric equations. That's an x equals some kind of equation with t or expression, and then y equals some expression with t. So we're going to solve one of those for t. It doesn't really matter which one, and so I'm just going to solve the first one for t. So that becomes x square root of t equals 1. So then the square root of t equals 1 over x. Then I square both sides, so t equals 1 over x squared. Okay, so then what I can do is I can take that 1 over x squared and plug that in for t in the other equation. So there's my 1 over x squared, and then remember that t was squared, so I'm squaring the whole thing. So to simplify that, that becomes 2 over x, not squared, 2 over x to the 4th. And so now we can just graph this like we would a normal rectangular equation. And so I am going to mark off my units. Okay, and I know I can't plug 0 in for x because it's on the denominator. And if I plug in 1, I will get 2. So I'm going to make each of these 2 again, just like I did the last time with the previous graph. And so when I plug in 1 for x, I get 2. So I have that point there. And again, I know that I can't have 0 as an x value. If I plug in 2, I end up with 2 over 16, which gives me 1/8. And so this is going to be like really far down here. And so when I look at the graph, it ends up being a curve like this where it's going up close to the y-axis but never actually touching. And then this part is going to go close to the x-axis but never actually crossing. Okay, let's take a look at one last example. Find a set of parametric equations to represent the graph of y equals 4x minus 3 using the following parameters. So for the first one, we know that x equals t, so we're just going to plug in t for x. And that is all you do. That is the answer. So that's the set of parametric equations. B has a little bit more work, but really nothing that we can't do. So if we know that t equals 2 minus x, so we want to get x by itself. So we're going to subtract 2 and then divide by negative. So negative t plus 2 equals x, or we can rewrite that as x equals 2 minus t. That just looks a little bit nicer. And then we can go ahead and plug that in to our x in the y equation. And so we can put in 2 minus t and then simplify that. So we get 8 minus 4t minus 3. So then we get 5 minus 4t. And so that is the set of parametric equations.